Hi, my name's Steve. We're back with another math challenge, this time the junior math challenge from 2016. This was done about 5 years ago in April 2016. And it's aimed, if you've not done any of these before, it is aimed at school-aged children in year 7 or 8, and that is about ages 11 to 13. But given that, it's tough. So if you are a adult looking back at this and you're thinking, wow, some of these are pretty deep, yeah, they are. So if you're a student practicing this for one that you're about to do in your school, this is how it works. You get an hour, and all the questions are multiple choice. You get A, B, C, D, E. The first 15 questions are free to guess, so you can guess any of those at the end of the paper. If you haven't done question 12, have a guess at it. But after that, you will lose marks for guessing, so please don't do that. The type of maths you'll see is different. It is not like maths you'll see in a test, not like maths you'll see in a lesson. Generally, it is using the maths you know to solve problems, which in my opinion is proper maths, or math if you're watching this from overseas. So if you want to have a go at this, the link in the description to the YouTube video is in below, and it has a link to this actual paper. So you can pause the video, have a go at it yourself and see how you do. I'm going to go through it and mark it at the very end and see how I do. I'd like to think I'm going to be able to attempt all the questions, but occasionally I make mistakes and I might not get them all right, but we'll see. So the way it scores, as you can see down here, so basically question 1 to 15 is worth 5 marks, question 16 to 25 are worth 6 marks, but if you get any wrong between 16 and 20, you lose a mark, and if you get any of the last 5 wrong, you lose 2 marks. So you're disincentivized to guess the last 2. Just enjoy it. The way I would suggest you approach this is if you work out the answer to a question, and if it's there, you're probably right. If you work out an answer to the question, it's not there, they're very good at putting wrong answers in, so just be careful. We're going to crack on, and we can see I'm doing this live on Twitch, so if you want to watch these live in future, follow the link in the description to my Twitch channel, and you can see me live right now, like Omega is watching me now. So we're going to do a junior on Omega from 2016. Let's have a go. So the first 5 to 10 are pretty straightforward and easy, and you should spend a lot of your time just making sure you're getting all those right before you get into the hard ones. Okay, it says which of the following is the closest to 0, so I'm just going to work them all out. So 6 plus 5 plus 4 is 15, 6 plus 5 take 4 is 7. You don't have to apologise. 6 plus 5 times 4, you do the multiplication first, that will be 26. 6 take 5 times 4, it will be 6 take 20, it will be negative 14. And 6 times 5 divided by 4, that will be 30 divided by 4, which will be 7.5. So the closest to 0 is B. No worries, the senior one should be up on YouTube now, Amiga, so if you want to have a look at how I did. I had a really foggy day. I misread some questions and so on. I ended up getting all but one right, but yeah, it was. I think it's because I was doing it really late at night. I found it pretty tough, to be honest. Which number is 21 less than 60,000? I'm pretty sure it's this last one here. If you add 21 to that, yeah, here's that one there. Yeah. Well, weirdly, I only got one. There was only one I couldn't do. That was the very last one. Although maybe given time, I was trying to stick to the time limit as well, so I couldn't do it in the time limit. And then I misread a couple of questions and got stuck. I just got like question 14 and 15. I misread, I got stuck. And if you watch the video, you'll see where I struggled. I think. One lap of a standard running track is 400 meters. How many laps does each athlete run in a 5,000 meter race? So how many 400s go into 5,000? We're just going to divide them. You can cancel out 2 of the zeros. So 50 divided by 4 is 12 and a half. 12 and a half laps. 50 isn't a multiple of 4, so you know it's not going to be a whole number. So you could have probably guessed 12 and a half straight away. In January 1859, an 8-year-old boy dropped a newly hatched eel into a well in Sweden, apparently in order to keep the water free of insects. The eel, named Ale, finally died in August 2014. How many years old was Ale when it died? Wow. Wow, okay, so how many years is it between 1859 to 2014? So 1859 to 1900 is 41. Plus 2000 is another 100, and then to 2014 is another 14, and we add those together, we get 155 years old. Those options actually made it a bit easier. But the options weren't even close, so they. What is the value of 1/25 plus 0.25? 1/25 is 0.04 because the 25 fours make 100. So you split it 100 into 25 bits, you'll get 4. So if you split 1 into 25 bits, you'll get 0.04. And that's 0.29. Right. Jill is now 28 years old and is a teacher of mathematics at a school which has 600 pupils. There are 30 more girls than boys at the school. How many girls are at Jill's school? I don't think you need that first bit of information, do you? So, if they were an equal amount, there will be 300 of each. So, if there were an equal amount of boys and girls, there will be 300 boys and 300 girls. There are more girls than boys at the school. So to get 30 more girls, you need to have 15 added onto the girls and 15 taken off the boys to keep the total the same, so 285. So how many girls are at Jill's school? 315. And that's how you get 30 apart. So if you want to kind of split something that was even to make it 30 apart, you have to half the 30, add 15 on and take 15 off. A distance of 8 kilometers is approximately 5 miles. That's true. Which of the following is closest to 1.2 kilometers? So how many 1.2s in 8? 7 1.2s make 8.4. So, oops. So how many 7s go into 5? How many 7s go into 50? 0.7. I think it's this. Yeah. So roughly, I'm just estimating here. Just what you're just trying to scale it up effectively. And this will be 5 and a bit because it's 8 kilometers, so 5 and a bit. So it'd be 7 and a bit, so 0.75. Yeah, that makes sense. Hey Vic, how you doing? I'm going to play your match in an hour or so. I'm going to finish this off, maybe have a break, get my mind back into bridge, and then play your match. What is the value of 2 plus the even numbers to 20 divided by the sum of those numbers, so 11. So the denominator is 55, and the numerator is going to be 110. That's 2. Yeah, you've got basically you can put them in pairs. That's twice as big, that's twice as big, that's twice as big, and so on all the way down to the end, which is going to be 2. There is an offer. I'm not going to take you up on the offer, I'm afraid. Did you play that badly? One of the 3 symbols, addition, subtraction, and multiplication, is inserted somewhere between the digits of 2016 to give a new number. For example, 20 subtract 16 gives 4. How many of the following 4 numbers can be obtained this way? So you can have 201 plus 6 gets you that. So we can do that one. You have 20 times 16 gets you that one. You can have 201 take 6 gets you that one. And to get 36, you'd have to 2 times 0.16 is 32. I'm not sure you're allowed that, but that doesn't work. And then if you have 20 and 16, there's nothing you can put in between them to get you in. Oh, you can plus, can't you? Put plus. Being stupid. You can get them all. That's fine. To be honest, I'll take a big in win and win the BAM by 1. which is, I think it's what you were offering me, wasn't it, roughly? You said, I think the offer was 3 times BAM if I get a 10-imp win. Right. The square is folded exactly in half and in half again. I'm pretty sure you could do that one and that one. So the original square could be like that, and you fold it there, and then you fold it again. So I think you do that one. You can fold the first square in diagonal, make like triangle sandwiches. I think you can probably do this. In fact, that one's the same as the C. So is it D? If you have a square and you fold it in half down that line, and then you fold it in half down that line, it wouldn't yeah, you can't fold a rectangle in half, so it's going to be D. A rectangle doesn't have a diagonal line of symmetry, so you wouldn't be able to fold it in half. If you folded the rectangle in half, you'd have a shape that looks a bit like that or something. Poorly drawn. Yeah, I'm not taking that off of it, sorry. Which of the following statements is false? 12 is a multiple of 2, that is true. 123 is a multiple of 3, that is true, that is 41 threes. 1234 is a multiple of 4, pretty sure that's false. I think it's C. That's a multiple of 5, and that's a multiple of 6. It is. So I'm pretty sure it's C. So the way I can do these quite quickly is I have some multiplication tricks. To see if it's a multiple of 3, if you add the digits up, if they equal a multiple of 3, then the original number does. Multiple of 5 is easy, it ends in a 5. A multiple of 4, the quick check with the multiple of 4 is you just check the last 2, because 100 is divisible by 4. All of the stuff bigger than 100 will be divisible by 4 because it's just some multiple of 100. So all you need to do is check the last 2 digits for a multiple of 4. If you check the last 2, is 34 divisible by 4? No, it's not in the 4 times table. The other thing you could do, you could just try and divide them. So if you divide 12, you get 300 and you're going to get 308 and a half, I think you're going to get for that. So it's going to be that one. And then to check it's a multiple of 6, there's no quick check for 6. What you do for 6 is you check, because 6 is 2 threes, you check if it's a multiple of 2, it is, and then you check if it's a multiple of 3, using the same multiple of 3 trick we did over here. Yeah, it is a multiple of 3 as well. So. The musical Rent contains a song that starts 525,600 minutes, which is the following is closest to this length of time. 525,600 minutes. Oh dear. Hey, Kiwi Game Romania. Multiples of 7. I do know a multiple trick for 7 and 11. The 11 is actually easier than 7. If you have a multiple, just while we're on it, if a multiple of 11, so if you have 6280159280, something like that, to check it's a multiple of 11, what you do is you add alternate digits together, so you would add those together. 2 plus 0 plus 5 plus 2 is 9, and then you would add the other alternate digits together. 9 plus 1 plus 8 plus 6 is 24. If they differ by a multiple of 11, then the original number is a multiple of 11. So that's the 11. 7's very weird. I could go into 7, but I think it's just a bit confusing, so I don't really. To be honest, with 7's, a quick check for 11, so that would be a quick check for 11's. I think that's quicker than trying to divide it. With 7's, personally, I will divide it quicker than the check, and so I think a check that takes longer than actually dividing it is not worth it. Right, the musical Rent contains a song that starts this. So a week has minutes, so there are 60 minutes in an hour. That gets you a day, and that gets you a week. So we could work this out potentially. 7 times 60 is 420, times 24 is 420 is going to be 1680, 20 of them. Not 8, not So that is number of minutes in a week. So it's not A. We're going to estimate this. So we're going to say there are 10,000 minutes in a week multiplied by how many minutes in a year would be 365. Yeah. So, am I doing something wrong here? 525,600 minutes. I've been told what the answer is in chat, but I've done something wrong, have I? Have I done something wrong? Thank you. It's 52 weeks in a year, so it's going to be that one. Yeah, thank you. I was doing days. Yeah. Thank you, chat. I knew I'd done wrong because they were so far off the answer that it didn't seem like a question they'd ask. The diagram shows 5 circles placed at the corner of a pentagon. The numbers 1, 2, 3, 4, 5 are placed in circles, one in each, so that the numbers in adjacent circles always differ by more than 1. What is the sum of the numbers in the 2 circles adjacent to the circle which contains the number 5? So if you had 5, they have to differ by more than 1. So more importantly, if 5 was there, 4 would have to go in one of these two up here. So let's put 4 there. 3 would then have to go away from 4. 2 would then have to go away from 3, and 1 there. So I believe the sum of the ones opposite 5 would be 3 and 4. If you put the 4 where the 1 is, then the 2 and 3 would just swap places. So it's going to be, what's the sum of the numbers in the 2 circles adjacent to number 5? It's going to be 5. In the diagram, AB equals AC, so they're the same length. And D is the point on AC such that BD equals BC. Oh, no, okay, got that wrong. Alright. So AB equals AC, so that means that's the same as that one, and that one is the same as that one. Angle BAC is 40. What is angle ABD? So the angle we're trying to find out is the angle ABD. We're trying to find this angle out here. So if A is 40, the angle A is 40, then the angle at C and B, because the whole triangle is isosceles, the angle at C and B is 70 each. They're going to be 70 each because it's going to be 180. And then because the angle DBC is isosceles, you can say that that's also going to be 70 because they're at the base of the isosceles. So if they're both 70, then this angle here is 40, which means the remaining angle needs to be 30 to make up 70. So it's going to be 30. Oopsie, if I've done something wrong, let me know. How many of these 4 expressions are perfect squares? Well, the good thing is I know my cube numbers. So that's going to be 1 plus 8 is 9. So that one is. The next one's going to be 1 plus 8 is 9, plus 27 is going to be 36. So that one is. The next one is going to be 1 plus 2 plus 3 cubed, which is 36, plus 4 cubed is 64. It's going to be 100. So that one is. And 5 cubed is 125. So you're going to get 225. Well, that's weird. I did not know that. I did not know that that was true. They're all going to be perfect squares. You're going to have 9, 36, 64, and so you're going to have, yeah, 9, 36, 64, 9, 36, 100, and 225. You just know that. I didn't know that. I did not know that. Does that always work for all of them? Right. More importantly, if you're doing this yourself, we're now past the point where you should be able to guess. So at this point onwards, we're not going to guess. We're going to try and work them all out. I didn't know that, Sam. Each of the 9 small squares in this grid can be coloured completely black or completely white. What is the largest number of squares and be coloured black so that the design created has rotational symmetry of order 2 but no lines of symmetry? Ooh. But no lines of symmetry. I think it's going to be... So that has rotational symmetry of order 2, but no line symmetry. And what you can't do is colour in those two, because that still has rotational symmetry order 2, but now you've got a diagonal line symmetry down this diagonal, so I don't think you can have that. So I actually sometimes struggle to do the rotational symmetries. I think it's very hard to explain without just doing it. So I think that's, you need like a zigzag pattern, a pattern a bit like a Tetris shape. So some Tetris shapes are congruent, but different in that if you can't flip them over, you can't get the other one. So I think you need something like that, which will spin. This will spin round, and it will look the same when you've gone 180 degrees. So I think it's that. Pretty sure you can't have any more. What I was looking for is like something like that, which would be, you could colour in more like that, because that again doesn't have a line of symmetry, but you can't make that shape without kind of connecting these two bits together or these two bits together, and then you just get something that doesn't work. So in a larger grid, I think there would be a better way of doing that. In a group of 48 children, the ratio of boys to girls is 3 to 5. How many boys must join the group to make the ratio of boys to girls 5 to 3? So let's work out how many there are. So if the ratio is 3 to 5 and there's 48, 3 plus 5 is 8. 6 of those, so you've got 18 and 30. How many more boys must join the group to make the ratio of boys to girls 5 to 3? So what you've got now is the ratio is 5 to 3. The number of girls is not going to change. The number of girls is 30, which means you need 50 boys. The total number of kids is now 80. So the number of girls doesn't change. To make it 5 to 3, you need the boys to be at 50, and that means 32 boys need to join. Yep. Cheers, beans. In the additional sum shown, each letter represents a different non-zero digit. What does the letter X represent? So you know off the top of your head, A has to be 1. Because to get a 3-digit number out of a 3-digit number, there's no way you can make it more than 2000. So you know A has to be 1. And E plus E is S, but E plus E is E. So when you do E plus E to get S, you must have a carryover. Otherwise, E plus E would get S again. So E plus E carries. So it must be 9 and 9. So I think you've got 9 plus 9 is 8 carry 1. And then you've got another 9 plus 9 gets you the 9 because the 1's carried. Carry 1. And then you've got S plus S is X. And then 1 carries over. So you've got S, S, X. So s plus s is x with a carry of 1. Now s and s have to be 5 or more because you need to get this one here. If s and s was 5, a and x would be both 1, and they have to be different. If s and s was 6, x would be 3 and a was 1. So I think, and then if s and s was 7, x could be 5. Oh dear, it could be both, couldn't it? Thank you. There we go, I knew this one I missed. 8 and 8, so x is 7. Thank you, I'm being stupid. I'm like, oh, it could be 2 different things there, but now I'd already worked it out. 3 boxes under my stairs contain apples, pears, or both. Each box contains the same number of pieces of fruit. The first box contains all 12 of the apples, and 1/9 of the pears. Apples or pears or both. Each box contains the same number of pieces of fruit. The first box contains all 12 of the apples and 1/9 of the pears. So we know that 12 plus 1/9 of x is the same as the other 2 boxes must have the same pieces of fruit in, so they must have 4/9 of x in. So 12 is 3/9 of x, or a third. 12 is a third of x, so x must be 36. How many pieces of fruit are in each box? X is the number of pears, so it's going to be 16. A cyclic quadrilateral has all 4 vertices of the circumference of a circle. All 4 vertices on the circumference of a circle. And that guy, I'm not going to read his name, gave the following formula for the area of a cyclic quadrilateral's edges of lengths A, B, C, and D. The area is S subtract A, S subtract B, and so on, where S is half the perimeter of the quadrilateral. What is the area of the cyclic quadrilateral with side lengths 4, 5, 7, 10? So the perimeter, this is just looks like a substitution. The perimeter is 10 plus 7 plus 5 plus 4 is 26. So the area is going to be the square root of 26 subtract 10 times 26 subtract 4 times 26 subtract 7 times 26 subtract 5. So that's going to be the square root. There'll be an easy way to do this. So 16 times 21 times 19 times 22, sorry, times 19 times 21. Half the perimeter, thank you. 13, 13, 13, 13. Thank you. So it's going to be 3 times 9 times 6 times 8. This is going to be 6 8 to 48. 3 48s are 144. So it's the square root of 144 times 9, which is going to be 12 times 3. It's going to be 36. I didn't do the math. The diagram shows the pentagon drawn on a square grid. All vertices of the pentagon and the triangle are grid points. What fraction of the area of the pentagon is shaded? Fraction of the pentagon is shaded. Yeah, I understand that, Sam. I'm just looking. Alright. So the area of the Pentagon is. So I think what you can do is that little bit there goes there because of gradients. That bit there goes there, and that bit there goes there. So I'm not going to count these three spaces. And then conversely, that shaded bit goes there, that shaded bit goes there, that shaded bit goes there, and then that shaded bit goes there. So I'm not going to count all those either. So I'm just going to count full squares. It should be the right number of full squares, and it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be 9 out of the area of the Pentagon. The area of the Pentagon is going to have 18, 27, 28, 29, 30, 31 and a half. It's going to be 18 out of 63, which is going to be 6 out of 21, which is going to be 3 out of 7. 2 out of 7, there we go, 2 sevenths, there we go. Yeah, I could have done it that way. Base times height, yeah, I did not think of doing it that way. That is a much easier way of doing it. Base times height, I know, yeah. I could have just done, yeah, for those people who did that a different way, you could just work out the area of the triangle by doing base times height and halving it. You get 9. You do 380. You do 3 6s and half it and get 9. I counted squares. I got tricked because they did it on squared paper. If they hadn't done it on squared paper, I would have spotted that. 4 copies of the triangle shown are joined together without gaps or overlaps to make a parallelogram. What's the largest possible perimeter of the parallelogram? So, my guess is that you could put them like that. And that's a parallelogram. It's a parallelogram because it's a rhombus. You know that this angle equals this angle, and then this angle equals that angle. So it's not it is a rhombus, but a rhombus is a parallelogram. So I think that counts. So I'm going to say it's 4/13 is 52. Can we do better than that? Why have they given us much larger answers? Why have they given us much larger answers? So if 52 is the largest answer here, I'd be sure I got it right, but it isn't. So I think potentially we're missing a way of joining them together. So oh, what about doing something like that? That does it, doesn't it? You get all the 13s and then 2 5s, so it's 62. Can we do any better than that? Oh, what about just making the short sides match the most? If we make the short sides, so do like this, but make the short sides match. So, and then we get 4 13s and 2 12s. It's 76. Yep. That's the best way of doing it. I'd have just got that wrong if they, well, yeah, like because I know that there are going to be different ways of doing it and they'll be most efficient. If my first one is 52, there's no way they put all these other wrong answers, because if 52 is the best I can do, their wrong answers are going to be lower. So I got reprieved there by their answering system. The diagram shows the first few squares of a spiral sequence of squares. All but the first 3 squares have been numbered. After the first 6 squares, the sequence is continued by placing the next square along 3 existing squares, the largest existing square and 2 others. So the next square is going to go at the top here. The 3 small squares have a side length of 1. What is the length of the 12th square? So this is just this is a weird Fibonacci sequence, I think. But it's a weird one because the next term in the sequence is, I mean, I could just work it out. We're going to get, so the 9th, then the 10th, then the 11th will go here, and then the 12th will go here. So I guess we're just going to work it out. So that's got a length of 3. That one's got a length of 4. That one's got a length of 7. I'll change to a better pen because I think you need to be able to see it. That's got a length of 7. That's got a length of 10. This is the side length of the 12 square, so this is going to have 17. The one that goes to the top now will have 27. The ones that goes down this side now will have 44. The ones that goes across the bottom now will have 71, and then the one that goes down this side here will have 105. No. 8th, 9th, 10th, 11th, 12th. Thank you. Yeah. 7 plus 1 plus 3. Well, I'll tell you what I did. I knew you don't need to add 3 numbers. So I added 2, but I did the wrong 2. I was adding 7 and 3, but it's 7 and 4. So that's 11. Then that's 18. Then this top one here is 29. Then this side one here is 47. And then this is going to be 153. And then this bottom one here is 76. And then this side one here is exactly what I said, 123. Exactly what I said. I'm just rubbish at the moment. Part of a wall is to be decorated with a row of 4 square tiles. 3 different colours of tiles are available, and the last 2 tiles of each. Part of a wall is to be decorated with 4 rows of square tiles. 3 different colours of tiles are available, and there are at least 2 tiles of each colour available. Tiles of all 3 colours must be used. How many different ways can the row of 4 tiles be chosen? Right, so the first tile So what I'm going to do is I'm going to say how many different ways are there of just choosing the 3 colours. So let's do the red, green, blue. So you've got red, green, blue. There are 6 different ways of ordering red, green, blue. So you can have red, green, blue, green, red, blue, so on. And you need to have one of each colour. And then the 4th tile can be of any colour and it can go in any position. So there's 6 ways of doing 3, but the 1, 2, 3, 4. There are 4 other places you can put this other tile, of which each of them can be 3 colours. So it's going to be 6 times 4 different places you can put the other tile times 3 different colours. So it's going to be 3 4s at 6. Oh no, I'm doing it wrong. Oh, but I've got to take off the repeats. So if I put it here and it's red, it's the same as putting it here if it's red. Okay. Alright, alright. So yeah, I think there's 4 different places you can put them, and there's 2 colours that matter because I don't want to count the same one twice. There's always a colour I can't count again, so I think it's 48. 6 times 4 times 2, because obviously if I put red here and red here, I'd need to discount that, so there's only one possible thing. Yeah, I think it's 18. I think it's 48. I might be wrong there. I probably am wrong, but yeah, I'm going to go with 48. I got an answer that was there, so that's what I'm going to go with, and I mark it at the end. Actually, it's got to be less than 4 factorial. 4 factorial will be how you can order 4 things, and that will be 24. It's got to be less than 4 factorial. If you had no choice and you were putting 4 things in order, there would be 24 ways of doing it. So it can't be these 2. So yeah, it can't be those 2. So Sam's right. And it can't be 24 because you've got a restriction. So I'm guessing it's 18. I'm going to go with Sam. He's got better working out than me. Right, well done, Sam. Beatrix places dominoes on a 5x5 board, either horizontally or vertically, so that each domino covers 2 small squares. She stops when she cannot place another domino, as in the example shown in the diagram. When Beatrix stops, what's the largest possible number of squares that may still be uncovered? So, if you did a domino and then underneath a domino, you leave this one uncovered, and potentially if you surround this one, you leave this one uncovered. So you could do a domino here, and then a domino here to get that one, and then you'd need to do domino here, and then a domino here to get that one, and then this one needs to be covered, so you do a domino that way, so you get that one, and then you've got one more row left, so you could do a domino here, and then one in the bottom to get that one, and that one. 1, 2, 3, 4, 5, 6, 7. Is there any way to get one more gap? It must be odd. You are absolutely right, yeah. It can't be even because there are 25 spaces to be filled, and if 8 of them were unfilled, that means 17 are filled, and it can't be 17. So because I can do 7, and I know it can't be 8 because it can't be even, I think 7's right. Right, that was one of the quickest ones I've done, but mainly thanks to the help I got from the chat. So thank you, chat, for correcting me when I'm wrong. We're going to check some answers now. I'm going to pop this over here. And we're going to go back to the start. So get yourself a green pen or some sort of marking implement if you've done this yourself. We're going to go back all the way back to the start. And we're going to mark it. Again, not been a stellar day for me, but I think we've got them all right today. Question 1 is B. Question 2 is A. Question 3 is E. Question 4 is C. Question 5 is A. Question 6 is C. Question 7 is A. Question 8 is also A. Question 9 is E. Question 10 is D. Question 11 is C. Question 12 is B. Question 13 is C. Question 14 is D. And question 15 is E. Now at this point, if you get any of these wrong, bear that in mind, you're going to lose some marks if you get any of these wrong. But question 16 is B. Question 17 is C. 1 sec, Vic. Question 18 is D. Question 19 is B. Question 20 is E. I'm just misreading questions today. Question 21, that could have been done so much easier. 21 is that. 22 is E. Yeah, to give the little diagram of what it should look like. Question 23 is B. Question 24 is D. Right. I'm going to disagree with you there, Sam. It's 6 times 3 times 3. Yeah, I had the right thing. I need to restrict one, but I need to restrict that one to 3 rather than that one to a 2. 6 times 3 times 3 is 36. 25 is D. So question 24 is not B, it is D. Yeah, you counted half. So the way they've done it, they've said you can do red, red, and then 2 others. Do red, blank, red, blank. You can do red, blank, blank, red. You can do blank, red, red, blank. And then you can do blank, red, blank, red. And then you can do blank, blank, red, red. And that's for red as being the colour that repeats twice. There are 6 ways to do it that way. There are 2 ways to put the 2 X's, and then there are 3 different colours you can have in place of the reds. That's how they've done it. It's not 6 times 3 times 3 either, so that's wrong as well. 6 times 2 times 3 gets you 36. That's how they've done it. Okay. No worries. You made me question myself. I actually thought it was a much higher answer than 18, and then I've convinced myself that it couldn't be higher than 24, which is obviously wrong. So anyway, let's go. So we're going to lose some marks for that one, aren't we? So what's our score? So our score today, we got 24 questions right, and they all get us. I've forgotten the scoring. It's we got 15 questions that were worth 5 marks. We got 9 questions that were worth 6 marks, and then we got 1 penalty, which lost us 2. So we're going to get 75, 54 minus 2. It's going to be 129, 127 out of 135. Boo! We didn't get full marks, but we answered every question. So how did you do? If you want to post in the comments below, you can let us know what score you got. You can let me know if you'd like what I'm doing. Please follow me on Twitch. The links are in below, and the links to this paper there too. You can also find the mark scheme on the same site if you want to have a go at some of the other ones. I've got other videos, and please feel free to do so. So thanks for joining me once more. I'm going to be back in a few days with an intermediate one from 2016, so if you want to do that ahead of time, and the video for that will be up within a week or so, and I will be doing it live on Twitch. So thanks so much. See you soon.